Hello, good evening, everyone.
Good evening, sir.
Good evening, sir.
Good evening, sir.
So,
Good
yes.
evening, sir.
So we are back.
Yes, sir. Yeah.
So did you people try binary files?
Yes, sir, I tried.
Any problem?
No, sir. Yes, sir.
Okay, let me open that file. The file that I sent you, let me open that.
Like a student, I did not try.
Sir, I can't see your screen.
I'm not sharing. First I
Okay,
open
sir.
my.
Okay. Okay, sir.
Good evening, Yogesh sir.
Good evening, Ji. So last Saturday it was what date? 25. No. 24. I don't find that file. Okay, fine. Not an issue. It was practice questions for binary file. I sent that file in that group only, है ना? In our group. Okay, I had to download from there. This is mismanagement. See, I had to scroll up so much due to all these thanks and thumbs and everything. Practice files. Okay, fine. So here I share my screen. And these are the questions. Now tell me, which question gave you a problem? Yes, tell me which question was giving problem. Someone said there was a problem in one question. If no problem, then we can move forward.
नहीं सर हो जाएंगे सारे
हो जाएंगे यानी कि अभी तक किए नहीं है
सारे नहीं किए सर
और अपने बच्चों से हम क्या क्या एक्सपेक्ट करते हैं ओके फाइन
सर एक्चुअली अभी दूसरा टॉपिक पढ़ा रहे हैं ना अपना जो
अच्छा,
अपनी क्लास में पढ़ा रहे हैं उसके ऊपर पूरा फोकस उसका मटेरियल तैयार करना पड़ता है
ठीक है क्या क्या पढ़ा रहे हैं आजकल
एक्चुअली मैं तो अभी एसक्यूएल पढ़ा रही हूँ तो
अच्छा,
ग्रुप बाय और जॉइन और वो सब पढ़ा रही हूँ तो
चलो ठीक है जी
बुक्स में थी बच्चों के पास ना
ये इसलिए मटेरियल तैयार करना
देना पड़ता है
ओके फाइन सो
हमारे 11 भी शुरू हो गया तो डबल क्लास
रिकर्शन शुरू करें फिर
श्योर सर
यस सर
okay how many of you don't know recursion at all anyone everyone knows recursion okay fine has everyone taught recursion at some point in school
Yes, sir.
Yes, sir. Yes, sir.
is there anyone who has never taught recursion Is there anyone who has never taught recursion? Is there anyone who does not know what is recursion? Okay, everyone knows. Fine. Then what I shall do is I shall try to write a few questions on recursion, and you can tell me wherever there is any problem. We can discuss that. Let me see the chat also. Okay, okay, fine. Okay. So in recursion, we shall write a few questions, some functions. Function to find the sum of first n natural numbers. I will write this. Def sum natural n if n is equal to 0, return 0, else return n plus sum natural. Any confusion in this function? Any problem? See, like it happens with our students also. The point is that
please mute your mic.
please, everyone, please.
Please mute everyone.
Okay. Now listen. See, like it happens with our students also. We have to prompt the students. Yes, any doubt, please ask. Don't hesitate. So here also I will say, if anyone is having any problem, don't wait for someone else to ask for that doubt or problem. If any problem anywhere, please ask me. Otherwise, it is simply writing the functions. Next function which I shall write is finding the factorial.
Sir, if we write if n equals to 1,
yes.
Then
now, because we are finding sum of first n natural numbers, n represents the number. How many natural numbers? So if this function is called like this, I want to find the sum of 0 natural numbers. So the output should be 0. If I run this, now if I say if n equal to 1, then return 1 like this. Like this, then I cannot pass 0 as the argument.
yes, sir. Yes, sir. Thank you, sir.
Because here n is not representing the natural number, n is representing how many numbers, the number of numbers. So it can be 0 also. Okay. The
Sir?
next, yes.
So in this case, while explaining it to students, do we need to make them understand about the stacks also? Because here we're going to have stacks. All the functions.
You may or may not use the term stack. Okay, you can make the diagram, make a stack. You can say that the process block is stored here with all the with the current status of the function stored here.
Sir,
Stored
please please once explain the working of the function so that we can make it clear to the students also, the way you do.
here. Okay, right. I
Thank
take
you.
an example. First with this smaller number, then with some bigger number. Okay, I explain it like this. This is the function.
Can I interrupt in between?
Always, always.
Yeah, sir, there is one very good site called pythontutor.com.
Yes, yes.
And
Here you
if
can
we
see the
try to
execution.
visualize the code there,
Yes.
it becomes very easy to explain.
Okay, let us do this one there. Okay. Let's do this one in pythontutor.com. Okay, this is the site pythontutor.com. Now here let me type the code. Def, let me say F1 to keep the things short. If n equal to 0, return 0.
Sir, copy paste हो जाएगा.
Else, चलो अब हो ही गया. N plus F1 n minus 1 print F15. Okay, let me run it. Visualize the execution.
else में colon लगा दीजिए.
हाँ जी. Okay, visualize execution. Okay, next. So where is the memory? Why is it not showing the values of variables? Now it prints. So it is not printing the value of n. Why? Next. So it is not showing me. Okay.
Sir, close this window. Sir, close this window. It is coming. Yeah.
Next. Okay. F1 and 5. Yes.
This is good, sir.
Really very good. But here when it becomes 0, after that return value 0. Next. Yes, do you see this? Return value 3, return value 6, return value 10, return value 15, and like this. So what I do is, how I explain to my students. This is the code. I tell them like this. That function f1 is called with the value of n equal to 5 or 3. So n equal to 3 and the function is called. And the function is called. When a function is called, computer keeps the track of the current status of the function of the complete program somewhere, and here it keeps a track. Okay, that the function is called from statement, some natural 3, and let me call this is statement number 1. So function is called from statement number 1. Function is called from statement number 1 and the current value of n is 3. Then control goes there. Value of n is 3. If n equal to 0, it is not 0. Then return n plus. It will return n plus. Again, the function is called. Suppose this is statement number 2. Because the function is called again from statement number 2. So this thing is kept track of. That call is made from statement number 2. And it is like this. 3 plus some natural 2. So again, this function is called. Now the value of n is 2. N equal to 0? No. Return n plus. Again, the function is called because some natural. So again, computer will keep the current status of the function. N is 2. And this is from statement number 2. So value of n is 2 plus some natural n minus 1, that is 1. Again, the function is called. Now the value of n is 1. It is not 0. So return n plus. So from statement number 2, it is 1 plus some natural 0. The function is called again. Now value of n is 0. If n is 0, return 0. It returns 0. Where will it return 0? From wherever the function was called. The function was called from here. So here the value 0 is substituted. Now 1 plus 0 is returned. Now it returns the value of 1 plus 0, that is 1. Return where? From wherever the function was called. The function was called from this place. So at this place, value 1 is substituted. Now some natural 1 is 1. So 2 plus 1 is 3. That value is returned due to this return statement. That value is returned where? From wherever the function was called. So this value 3 is returned here. 3 plus 3 is 6. This value is returned where? From wherever the function was called. From this statement, statement number 1. The value 6 is substituted there. So here I have written s equal to some natural. So this value 6 goes to the variable s. And then I say print s. This is how I explain to my students. I don't use the term stack. If I taught stack already, then I can use the term stack. Then I can say that it keeps track of the current status. I don't use the term process block. Later on, when I teach stack, then I again tell them this. Do you remember in recursion, it was keeping track? So the last call to the function was executed first. It was reverse tracking. So that place where it keeps track of the current status of the function is called stack. That is also a stack.
Thank you, sir.
No, see, if there is some better way, we can explain, like someone told me that Python tutor. Yes, I teach them Python tutor in the beginning only. when I go to script and then I'm explaining how if else is working, loops are working, then this Python tutor is very useful. But when I reach this place, recursion, I simply forget that yes, from Python tutor also I can teach that. So Python tutor is a good place. Is that fine?
Excuse me, sir.
Yes.
Excuse me, sir.
Yes, ma'am.
Sir, are we supposed to teach the comparison between recursion and iteration, that which is better and
No, I
when
don't
should?
teach. No, I don't teach because that becomes a bit complex. If you see recursion gives you more efficiency in Python. But actually speaking, recursion is not more efficient than iteration in other languages.
It is slow. It is slower, and memory needs are also higher.
Yes. Because it needs a lot of overheads, the recursion.
Yeah.
Keeping track
Function
of the
overheads are high.
status.
Yeah.
Hello.
Yeah.
Tell me, ma'am. Hello. So is that okay?
Yes, sir.
Okay, fine.
Thank you.
Okay, fine. So let us write another function, a recursive function. Let me minimize this. Okay. So the next one is finding the factorial. Should I write that or you can write it?
Written.
If n equal to 0, return 1. Else return n into
N minus factorial of n
minus 1. Should we discuss this? Should we discuss this or fine?
It's fine, sir.
Sir, thank you. Fine, sir.
Okay. Finding the nth term of a Fibonacci series. Finding the nth term of a Fibonacci series. If n is less than or equal to 2, return 1. Else return Fibonacci n minus 1 plus Is that fine? Or something to be discussed?
सर नहीं आया समझ ये वाला.
Okay. See, in Fibonacci series, first two terms are defined. First two terms are 1 and 1. And after that, any term is sum of previous two terms. So, nth term of Fibonacci series is n minus 1th term plus n minus 2th term. plus n minus 2s term. But this thing is not applicable for the first term and the second term. So the function is defined recursively if the value of n is greater than 2. Otherwise, it is not defined recursively. So these two become the base conditions. Value of n equal to 1 and value of n equal to 2. Everyone knows what is a base condition? Okay.
Yes, sir. Yes.
So these are the base conditions. So first I handle the base condition. If n is 1 or n is 2, so it means if n is less than or equal to 2, then no recursion. Simply return 1. Otherwise, return what? Return
Right.
of these two terms.
Right.
Okay. Where is my mouse pointer? Okay. Then let us say sum of all the elements of a list. Or first let me write to check whether a given string is palindrome or not. I take a string and check whether it is palindrome or not. If the length of string, if length of this string, or let me say L is equal to length of this string. If this length is less than or equal to 1, okay, if it is an empty string or string of one character only, then it is palindrome string. And if it contains more than one characters, then I have to check the first and the last character. These should be equal. If S0 is not equal to S minus 1, then return false. Otherwise, return palindrome S12. So this is how to check whether a given string is palindrome or not. Is that fine?
Perfectly fine.
I will get out
Hello?
of this. Hello.
Hello. Sir,
Yes.
could you please explain the length portion first wala?
First वाला उसकी basically जरूरत नहीं है,
Yes.
छोड़ दो. If length of
Then sir, last return palindrome.
okay.
How it is true?
Okay, first let me say
How is true?
print palindrome Nitin, print palindrome Naveen. Run it.
palindrome लगाया है second function.
पहले में आई नहीं लगाया, दूसरे में एन नहीं लगाया. ओके. देखिए मेरे पास एक स्ट्रिंग है 0, 1, 2, 3, 4, -1, -2, -3. अब अगर मेरे पास ये जो स्ट्रिंग है, if the string is blank, or if the string contains only one character A, B, C, D, then it is palindrome. So if my string has the length 0 or 1, then of course it is palindrome. So return true. And if the first and the last character do not match, then the string is not palindrome. So elif first character does not match the last character, then the string is not palindrome. But if the string contains more than one characters, first and last character also match, then we have to check this part of the string. If these two characters match, then this string should also be palindrome, the remaining string. So I have to check this. Else return palindrome, the string starting from 1 till -2. Getting it? My handwriting on the screen is like this only.
Sir, is it -2 or -1? I mean, you have written -1. But you're
If
saying
we say -1, it will go till -2 only, because last value is.
Okay, okay, got it, got it. Thank you.
Is this clear? Palindrome.
Yes.
Yes, sir. Sir, very clear. Sir, how can you say you are comparing string 0 and -1, and then you are returning if they are not equal, or if they are equal, then they are palindrome. Otherwise, if they are not equal, they are not palindrome.
See.
Only first and
No, no,
last digit.
no,
How
no.
you can decide, sir?
See, it is like this. For example, in case of Naveen, first and last match. First and last are matching.
Yes, sir.
Yes.
So it will come to this else. Return palindrome of this portion. First and last are matching, and this string is also palindrome, then it is true. If these two are not matching, if it is like this, then string is not palindrome, it is false.
So basically, in the recursive call, we are slicing the string, and now my new string becomes the next part.
The inner string. Yes.
Inner part. That is actually happening.
Yes.
And like this, your string is getting all
Reduced.
characters are
Yes,
getting
yes.
checked one by one.
Yes, yes. Suppose it is Malayalam.
एक मिनट आना.
First and last are equal. फिर इस बीच को चेक करेगा. First and last are equal. Check the remaining.
Yeah.
First and last are equal. Check the remaining. Suppose it is like this. Malayalam without A in between. First and last equal. Check in between. First and last equal. Check in between. First and last equal. Check in between. First and last are not equal. First and last not
we are
equal.
not appending the string, na? Just we were doing in the previous question, we were adding to the stack. Here you're writing palindrome S 1:-1. So it's fixed.
नहीं, इसमें देखो आपका सिंपल रिटर्न लास्ट में होगा. आपकी जो recursive call है, that is being executed with the sliced string.
Okay. Yes. Got it. Thank you.
Right, because here we are not maintaining any value. Return, we have to simply return the true or false.
Yeah. Thank you, Chaya.
Right? Okay.
Okay, got it.
Is that fine?
Yes, sir. Thank you.
Anyone, any other problem in palindrome?
No,
Okay.
sir.
Now
No,
let
sir,
us
it's fine.
find
Thank
the
you.
LCM of two numbers. LCM of two numbers A and B. Okay. First, I shall explain the logic which I am using, or it is better to find the HCF first. That is a simpler logic. How much time is left? 2 minutes. Okay, I can finish it. For the HCF, the logic goes like this, that Euclid's algorithm. I have two numbers, A and B.
I hope everyone must be knowing this.
HCF?
Yeah.
So I should not do it? Recursive?
No,
But
sir.
I
all
don't
know
think
this.
there
This is okay.
Yeah, this is
This is
everyone
okay, I
knows this
think.
procedure.
We have been doing it in C++ as well. As
Yeah.
No,
questions are almost
This
the
is
same.
not with
The
recursion.
logic remains same.
Okay.
sir, but
Sir,
the procedure
continuous
everyone
division
knows,
wala
na?
procedure hai na? The continuous division we are following, yes.
Okay, so I should not write this function.
I think this is okay. Rest others may say their viewpoint.
LCM.
If anyone says it is not okay.
सर करा दीजिए please.
Okay. So let me take two numbers, 15 and 12. I want to find their HCF. 15 divided by 12, 12 ones are 12. Remainder is 3. Remainder is not 0. If the remainder is not 0, then remainder becomes the divisor. And whatever was the divisor, that becomes the dividend. Again divided, 3 4s are 12. Now remainder is 0. So we stop. When the remainder becomes 0, whatever was the last divisor, that is the HCF. So what we do is define HCF with two numbers A and B. Divide the first number with the second number. If A remainder B is 0, then return B. Whatever is the divisor, that is the HCF. If this number is not a factor of first number, then again I have to find the HCF of these two numbers, the previous divisor and the current remainder. Return HCF of previous divisor was B and the remainder is A remainder B. So this is the function to find the HCF of two numbers.
Sorry to interrupt, sir. Just 1 second. Before doing this, don't we need to check if A is greater than B? Like which number is greater than of the two?
Doesn't matter. Doesn't matter.
Should we take this thing into consideration?
No, unnecessarily we are putting an if for the LCM recursively. So to find this recursive LCM, what I do is, see, define LCM of two numbers A and B. First, find their smallest factor. How to find the smallest factor? For I in range A plus 1. If I is a factor of A as well as a factor of B, then I is the smallest factor of A and B. Then break here. But if I don't find any number which is a factor of A and B, then it means the smallest factor is 1. Here I am finding the smallest factor of both these numbers, common factor, not the HCF. I am finding the LCF, lowest common factor. if this lowest common factor is 1, it means the LCM is A into B. Otherwise, the LCM is whatever is the smallest common factor into LCM. Now here comes the recursion. LCM of quotient.
Double slash.
Floor division.
Okay.
This is the recursive LCM. Please bear with my handwriting on the screen.
Sir, in this case, have you considered which of the two numbers is bigger? Or
No.
I can take anything here, B plus 1 or A plus 1.
Take anything. And this is to start with 2, not with 0. Range.
You आपका बना हुआ है भी बना देते हैं बस ठीक है ना
चलो ठीक है जी तो ये लास्ट फंक्शन करते हैं आप बना के दो जी जिसको जो कुछ बना के देना है घर भी बहुत जरूरी है
Sorry.
Hello. I know. This time teachers are doing a lot of jobs. घर संभालना है, खुद सीखना है, स्टूडेंट्स को सिखाना है, फिर उसके लिए वेब मटेरियल बनाओ, पावर पॉइंट बनाओ, प्रोग्रेस बना के रखो. क्लास लेना is very easy. Face to face, the real class is very easy.
Hello.
Hello.
Sir, please, could you please explain it again? Actually, क्या है? On the time your connection was not proper, so voice was not clear. Could you please explain
Okay,
this, sir?
fine. I will explain this. So what I do is the logic applied here is my voice clear right now?
Yes.
The logic applied here is this.
Sir, please mute everyone.
Okay. So a good example was given. Suppose the numbers are 18 and 24. I find the smallest common factor, that is 2. And now the numbers are 9 and 12. Now if I forget this portion, basically what am I doing after this? I am finding the LCM of these two numbers, 9 and 12. Smallest common factor. Now if I forget this step, this portion, basically after this I am finding the LCM of 3 and 4. Finding the LCM of 1 and 4. That's all. So what I am doing is I am finding the smallest common factor. If the smallest common factor is 1, for example here, the smallest common factor is 1, the LCM is the product of these two numbers. And if the smallest common factor is not 1, then the LCM is whatever is the common factor into LCM of whatever are the quotients. A floor division, whatever is the factor, and B floor division, whatever is the factor. Are you getting it? This is the logic.
Sir, I have one question.
Yes.
Like in this for loop, we started with I as 2, right?
Yes.
So if 18 modulo 2 equal to 0 and 24 modulo 2 equal to 0, in both the cases my condition is true. So I'm breaking out of the for loop.
Yes. Now value of I is 2.
Right.
So it will return what? 2 into
Okay.
LCM of A upon 2, that is 9, and b upon 2, that is 12.
Okay, sir. Got it. Thank you so much.
Is that fine? Or should I explain once again?
Fine, sir, fine.
Thanks, sir. Thank you, sir.
So what usually I do is, I give some functions like this to my students. I don't say write the recursive function for this, all these predefined things. I simply say, if a function is defined like this, that fx is equal to 1 if value of x is 1, and this is equal to 2 into fx minus 1 for the values of x greater than 1. Write a recursive function in Python for this. So they know that this is the base condition, and in else they have to write it like this. So this concept is clear that yes, the function is defined recursively. So we can create any such functions. Is that fine?
Yes, sir.
Yes.
Finding the sum of elements of the list, linear search and binary search, I'm leaving it to you. Next time we can discuss that. And what should we take up next, if next class is needed then?
So Python connectivity with SQL.
Okay, right. Right, I will take up that. Fine.
Yes, sir.
Okay, next time these remaining recursive functions we shall discuss if there is any problem, and then we shall move to
एक और
Python
topic है
connectivity.
program efficiency.
Program
Sir,
efficiency.
there is one. Yeah, उसमें clear ही नहीं होता कि to what extent you are supposed to teach children, because it becomes highly mathematical and it is very difficult to explain कि that login from where it is coming, or like people with a mathematics background will only understand कि how many comparisons are
So
there.
is it still there in the new syllabus? I don't remember.
Yes, yes, it is there.
Yes, sir, it is there.
It is there. I
Okay.
It
suppose
is
that
there,
is
but
the
not to
that
that
we should take
extent.
up
It has
first.
been reduced little bit,
Okay, fine.
but it is still there. So I think that topic, if you can take up, sir.
Okay, next time we are taking up connectivity, and then we shall take up that
Okay,
also.
sir.
Program efficiency.
Okay.
Sir, will you be sharing questions on recursion, assignment kind of things?
I will share these functions also which I have written. I will share the assignment also.
Thank you, sir. Thank you so much.
Okay, bye bye.
Bye, sir. Thank
Thank
you.
you.
Thank you so much.
Bye, sir. Thank you.
Bye. All are welcome.
Thank you, sir. Thank you so